Hello everyone. So we are back with another banger. So today we are going to be looking at multiple integration, specifically iterated integrals. So in general, before I mess up my example, let me find somewhere to write. Okay, so if you are given a function f in f and y, okay, and then you are told that, and then you are supposed to integrate that function like this. So what you want to first do is to integrate with respect to x. Okay, so if you integrate with respect to x, y is held constant. So for example, let's say you are given this, that you should integrate 2xy dx like this. Okay, so you have to first, you have to if you look at this, urukunzi integrate with respect to x. Okay, so for you to integrate with respect to x, it means that you have to take y as a what? As a constant. So we are going to factor out y here, or to try to separate this like this, 2x dx. Then after this, you then have to say, after you integrate this, you get what? That's x squared, right? Okay, because it's over the 2 in the denominator will cancel with these 2, produce x squared. X squared plus c. Okay, c, remember the constant of integration. Then when you expand this, you find xy, x squared y plus c y. Okay, c. So aba patangonyora sekuti y is a function, c is a function in y. Okay, so that this is the answer that you want, that you will get. So usavhunduke ukasangana nema questions akaita so kumberi kuti chaita anonzi partial derivatives, and look at the Jacobian. I love the Jacobian. Akaipa yakambonivhara saka ndoida zvingaiti. Okay, so let's look for at this example. Okay, no example yatatoita kai. No, we haven't done it. Okay, so as I have told you before, but we could integrate with respect to what? To x. So what we are going to do, solution. What we will do is we will integrate with respect to what? To x. So let's plug in our what? First of all, we want to factor out the part that we are saying it's a constant, because we are integrating with respect to x. So y will be a constant. So we are going to factor out y like this, and then we will be left with 2x dx. Okay, let's not forget the what? The limits. Then after this, we will produce something like this. This will be what? We put these big curly brackets, square brackets. Then this will be x squared plus c y like this. Okay, so we are moving from 1 to 2y. We are integrating from 1 to 2y. Okay, so remember, when we plug in these values, the y it will disappear. Okay, so we can forget about this part. Okay, so let's evaluate our limits. Y, then our limits, we're going to put the upper limits. Let's do this first. Will be 2y squared. Okay, minus our lower limit will be what? Will be 1. Okay, squared like this. So it will give us, forgive me for that was a big mistake. So we are supposed to write 4y cubed minus y. Perfect excuse. Okay, so that is our answer. It makes sense for us to have the variable that we are integrating with respect to in the limits. For example, if you look at this example, okay, as we one lower limit is written in terms of x, upper limit is written in terms of x. It does not make sense for us to have my variables my limits akanyorwa in terms of the variable that we are integrating with respect to. It cannot happen as is possible. So we are going to evaluate our next example. Evaluate is to identify kuti tiri kutanga taintegrate with respect to what. So in this case we are doing this with respect to y. Okay, so since we are doing this with respect to y, we need to make sure that we hope x in this case is not a variable, is a constant, because we are integrating with respect to what, to y. Says I'm going to the last section. So we can split this integration, or we can expand it to say that the integral from 1 to x so it's Django amazing, guys, right? So 2x squared, okay, the integers are x pekutanga tinowana chi negative 1 over x, something like this, so and it plus, because tina negative uyu and it tozoita negative subtract this lower bound inobva ita plus 1 with negative 1 over 1 todai so plus 2 and todai so. Then for these two is x, which is x squared over 2 minus 1 over 2, something like this. Okay, so this part tika expand munosara muna awana x1 cancelana kapo osara in negative 2x plus 2x squared plus x squared. Remember uyu na uyu vanocancelana, uyu umultiply ne uyu osara vari minus 1. If you expand this, I hope okay, if you expand this, we have no other term in terms of x, only negative 2x. But here I think we can add this to 3x squared minus 2x minus 1, something like this. This will be your final answer. Okay, so that is it. Let's stop this video before it gets too long.